Welcome again to the Southwest Climate Podcast, Monsoon 2021, first edition. Mike, dare I say it's here.
We made it. Can you believe it?
Make it.
Yeah.
We did make it. We've got a couple topics to discuss today. First one, Mike, we should do a little retrospective on June, and particularly the extreme heat, not just here in the Southwest, but pretty much across the West. I mean, there was a major, unprecedented, actually, in some cases, like really the extremes in some areas of the Pacific Northwest were startling. Let's talk a little bit about that, juxtapose the heat wave here and the heat wave there, and then our favorite topic, let's talk about the beginning of the monsoon. Finally, I'm really excited about this. We can discuss the monsoon fantasy game that generated quite a lot of interest. Actually, I did somewhere in the vicinity of like 8 interviews. It was pretty funny. Like the monsoon is kind of candy-ish. Everybody loves it, and like the media, like they picked up on it and they helped us out quite a bit. So we got a number of people playing our monsoon fantasy game, and we're really excited about it, Mike. And maybe we can go over but let's go over our July forecast for the 5 cities, you and I.
Sounds good. Yeah, good job on that full court press on the media there, man. Did you have somebody kind of dealing with the phone calls and scheduling your interviews and getting you prepped?
I did not, actually, I wasn't even aware that they were going to film me, and I kind of showed up in like a V-neck t-shirt, and like my hair is like, it needs to be cut. I haven't cut it since COVID. It was pretty funny. Don't
you love the idea in 20 years, your son's going to be able to find those clips online? That to me is precious.
Yeah, it's going to be quite embarrassing, actually. Okay, Mike. So yeah, there was a couple events, heat events in particular, that we should talk about. June ended up becoming in the books the warmest month on record for Arizona. And in the middle of that, Mike, there was right around, I think, actually the 14th, 15th, and 16th. Actually, for 8 straight days in Tucson, there were temperatures above 110 degrees. And that was a pretty long string of things, not unprecedented. And we'll talk a little bit more about this. Let's sort of get your take on what were the conditions that sort of set that up?
It was weird because the spring had been fairly mild. I mean, it was still above average for both April and May. They ended up, most of Arizona ended up being above average. And we can't forget New Mexico. New Mexico's had a really kind of different spring, especially the east side of New Mexico. And that's where it always gets kind of interesting, is New Mexico kind of gets broken down the middle and can kind of get lumped in with Arizona in some respects. And then the east side on the Great Plains can end up having really different spring weather. But we were going through April and May. We ended up having, quite a bit of unsettled weather, especially the end of April, kind of extended into May, kept temperatures somewhat cool. Northern part of the state, both Arizona and New Mexico, were getting some precipitation and some high elevation snow through late April and into May. It had 2 effects on me. Okay, so it's not like last spring, so maybe that's a good thing. We hadn't kind of kicked into the heat wave like we saw April of 2020 and May of 2020. The weather pattern with these troughs kind of coming through made me worried. Made me worried that this was going to kind of linger into June and start to beat back the progression of the subtropical ridge north and cause trouble for the monsoon onset. Because I'm gun shy after the last couple of summers. And so, but the thing is, and I remember thinking this a couple of years ago, is that what happens in May isn't necessarily a precursor for June. And you can't necessarily carry that forward. There isn't always a lot of persistence. And so what ended up happening was in the beginning of June, we started off right on track, right on average. And then quickly the subtropical ridge just built in on top of us and even pushed north and pushed right over the Four Corners. And so we had this amazing kind of core of monsoon position of the Four Corners high right over the Four Corners, and the heat just built right underneath that. So it was early. You don't usually kind of see it build in that far north. We baked under it for a couple of days, but then on the flip side of it, the moisture from the south, the monsoon moisture, was able to really kind of move up through Mexico quickly. Mexico got some precipitation and some convective outbreaks really quickly, and we were starting to get an easterly flow. So we're not only getting some really nice moisture out of the southeast, but we were also initiating Gulf surges really, really kind of early, typically in the season.
So, Mike, it has been an above average, a warm June. It was a warm June. We've seen those. That's a persistent trend for the most part. We've talked about that a lot before, but there's been, every single year that we have these heat waves, and inevitably we get one in June. They're quite common. Inevitably, there's the narrative of climate change. So I guess the question that I want to throw out to you is what we experienced in June here in the Southwest sort of is that not unprecedented, but is this different than what we would have expected, or does it fall within the bounds of sort of what we normally get?
It's a tough question to answer definitively. And so the way I had been thinking about it is that the trend in temperature, definitely climate change, mostly driven by climate change here across the Southwest in particular, it raises the floor for these heat events to jump off of, right? And so what we saw with this particular event, to me, didn't look all that particularly unusual when you looked at a weather map. Having a ridge build over the west through July is part of the progression of the seasonal shift here and the progression into the monsoon season. So it happened quickly and early. The wave pattern that our ridge was part of, extending back across the Pacific Ocean, may have had some upstream forcing by a typhoon or tropical storm in the West Pacific. So that energy going into the jet stream, and we've talked about this before in the podcast, because it can have implications but in the fall, you can get this sort of absorbing of these storms into the jet stream, and they can cause patterns downstream. And sometimes the patterns will get kinked up and they'll actually turn into blocks, which is what ended up happening with the Pacific Northwest heat wave. Our pattern, it didn't look that unusual, but overall, it's like the extent of the ridge, the magnitude of the ridge, things that we measure, so there was a lot of chatter around the measurement of the 500 millibar level taken, at some of the sounding sites here in Arizona, and in particular, Flagstaff had reached 6,000 meters. And that's, if you look in the historical record, is rare. You don't see that happen very often. And you see it with increasing frequency more recently than you do in the historical record, right? So that's part of the trend. So that's part of just sort of this sort of floor changing on these events. So these events they're easier to reach new temperatures. And our event was definitely record breaking and a couple of degrees off of some previous events. It's still at a duration that was, a week long, which, it's not unprecedented, but it was certainly noticeable. It broke records. So it has sort of, kind of two aspects of it. It wasn't completely solely caused by climate change, but climate change is definitely an exacerbating factor of this sort of kind of normalish weather event you'd see in Arizona in the summertime.
I was on a radio broadcast. I occasionally go on the Bill Buckmaster show and talk about climate. And it was at a time, I think it was like right in the middle of, right around the middle of June, right, like 3 days into it. And, he asked me live on air, like how unprecedented it was. And I kind of like screwed up the answer. I kind of had done a little bit of due diligence and looked at Tucson's record data, and and the highs it wasn't the most extreme temperatures we had seen, but that's also not a very good answer. Like, so what? So it's not, it didn't break any records, but that still doesn't mean that there's not a sort of a human fingerprint in it.
The heat ones are easier to do attribution with because temperature is more directly attributable to changes in greenhouse gases, right? And so, often what we'll say is that, could it have happened without climate change? Yes, absolutely could have. Is it more likely to occur with climate change? Yes. Does the frequency of these types of events in the future increase the probability of them increasing in the future? Yes. Those are all true at the same time. To me, it's helpful. It's two things. We have inherent exposure to weather and climate disasters, regardless of climate change. And we don't do a good job often of dealing with that exposure. Climate change makes that problem that's already been existing, and it exists more into the future as we, have more people living in different areas, and changes in patterns of urbanizations and demographics and that kinds of things across the West. It just makes those inherent issues on exposure more critical and a more pressing problem as it continues to get warmer out here.
I wanted to clean up my answer on his show a little bit, so I spent.
Here's your chance, man.
Yeah, I spent this morning doing a little bit of analysis to try to contextualize a little bit of that mid-month, mid-June heat wave that we experienced. So I've got some figures to report for Tucson, and I only looked at Tucson weather station at the airport and Phoenix's station at the airport. And so I looked at, I just defined a heat wave here as the 3-day average temperature. The highest average temperature for a 3-day period in June ended up being 108, or no, sorry. Looks like 100, a little bit more than 113 in Tucson, and about 117 in Phoenix. Now that's a 3-day average, so pretty high. But it looked like that was the fourth highest 3-day maximum average temperature in Tucson. So yeah, not the highest one, but hey, there's only 4 others from 1950, so a 71-year period from 1950. To 2021. So that's the 3-day period. Then I looked at, well, how many days, what's the maximum number of consecutive days of 110 degree temperatures or above in Tucson and in Phoenix. So the maximum number of consecutive days. So this year the maximum number was 8. And we actually had 2 years, 1990 and 1995, Mike. I don't know if you remember those years, but that had 10 days consecutively. In Phoenix actually is an interesting case, and we could talk maybe a little bit about this because the highs with Phoenix and Tucson were very similar during that heat wave. And there was a particular reason why that was the case. And normally Phoenix is a couple degrees warmer than Tucson, but yeah, so let me just follow that up with Phoenix. So the number of consecutive days in Phoenix with 110 degrees Fahrenheit or greater was 11. And honestly, Mike, last year is so anomalous for Phoenix. It's startling how many consecutive days there were with 110 degrees temperature or greater. So
yeah, it's like double the previous record or something like that, right? I mean, it just stands out as a crazy number.
Yeah. So I guess the point of this is yeah, it was a pretty unprecedented and extreme event. Not record breaking, but top 5 is something that we should pay particular attention to. So
and again, it's 2 year. I mean, it depends on how you slice and dice these, right? Is we had a run of days of daily records broken consecutively. So that's kind of like one way to define the how unusual this heat wave is. I almost think that sometimes these extreme events are distracting from, say it's a June where every single day is above average. That's as consequential and is part of the trend, but maybe wouldn't make the news, and is maybe even more indicative, of climate change because it has so much trend associated with it. It's so much part of the trend. Whereas these extreme events, when you really reach up, they have a climate change contribution to it, but it's also often sometimes something unusual about the weather pattern that has driven them. I don't know if that was as much of an issue for this particular one, but I expect that when they do weather attribution studies where they run climate models to try to diagnose the chance of this type of heat wave occurring with or without climate change, is that they'll get a better sense of what the proportionality of the weather versus climate is. And again, it's almost a done deal. The way these weather attribution studies work is that climate change will have been part of increasing the risk of this type of event.
The Phoenix temperatures, they were, the top was taking off them a little bit by, I'm drawing a blank on the fire, Mike, the one up in Globe.
The Telegraph fire, yeah.
Yeah, the Telegraph fire. I mean, it was really interesting that the day with the highest temperature, I think, in Tucson and Phoenix, that day, the temperatures were both the same at 100, 115. And it probably would have been, closer to 118, 119 in Phoenix, but the telegraph fire smoke was blowing over the city. So and people were like, oh wow, Tucson and has the same temperature as Phoenix, but the reason was because of that big fire.
Yeah, I remember I was driving back. I had a meeting in Phoenix that day, and I was driving back from Phoenix and watching the car thermometer not change between Phoenix and Tucson was a little disturbing, quite honestly. It was an event for sure. I mean, it was an impactful event. It was a dangerous, heat health event, and it's something that we should definitely be concerned about going forward.
So you talked about something a little bit that I found was interesting, and that is the temperatures at the 500 millibar height level were much warmer than they typically are. And, that's kind of a metric that, I don't look at very often, but can you talk a little bit more about that?
Yeah, I mean, it has to do with basically the measurement of the heat of the whole column. So it gives you it gives you kind of a sense of the strength, and you can look at the magnitude, the expansiveness or the extent of the ridge pattern across the West by looking at some of these metrics as well. But the 600 meter level, so 6,000 meters at 500 millibars. So meaning that when you launch a balloon, it's got a little barometer in it and it's going up and the pressure is decreasing very quickly. So, but the height at which you'd expect to see some of these pressure levels is going to be proportional to the temperature of that whole column of air, right? So 500 millibars is a pressure level, and that pressure level will go up or down based on how hot the air is below it, right? So in the middle of winter, that 500 millibar level is going to come much closer to the surface, and in the summer, it's going to heat up. So when we look at a whole ridge of high pressure system, where the highest heights are is kind of the ridge axis and can be the center of the high pressure system. And those values were exceeding 6,000 meters, which again, if we look at the climatology and you can look at, data sets going backwards, and you can look at the radiosonde observations across the West going backwards, and that just doesn't happen very often. So it was an indication of the strength and the heat that was kind of underneath this big ridge.
And so higher surface temperatures would mean higher temperatures. Yeah.
Yeah, absolutely. Yep.
Okay. All right. So then, fast forward a week, I think, or maybe a little bit more. And then there was another extreme heat event, but in the Pacific Northwest. And this one gained a lot of media attention. And there was some really eye-popping records in some stations. There were some highs in, Seattle and Pacific Northwest, Oregon, that there's a lot of records being broken during that heat event.
Yeah.
That had a different synoptic pattern than our pattern down here.
There are 1,000 articles online and good infographics and that kind of stuff to really deep dive into this. And, what I'll simply say is it was different. It was a different pattern. They don't typically see a broad ridge of high pressure like we have down here in the Southwest and sort of a normal transition. They had a strong, highly amplified jet stream, and it was in a pattern, what we call an omega block, which if you can imagine the jet stream carving out the Greek letter omega, and that particular kind of jet stream pattern is reinforcing. So it doesn't move. So it's a large kink or wave pattern in the jet stream, and it tends to sort of really lock down and create strong areas of high pressure that are hard to budge. They don't tend to break down real easily, and they can persist. And so I think that just having that at that latitude, this time of year with long days, created those extreme conditions. And I'll be really interested to see a lot of the studies that really kind of do a deep dive into, not only the meteorology of the event, like what were the sort of subtle aspects, like, Zach, you were talking about, is that that creates stagnant air masses. It changes the typical advection pattern where you might get, onshore breezes extending up valleys. Maybe you had downsloping winds in some situations which would have increased the temperature at the surface. And then the weather attribution study, aspect of it too. It seemed more like a extreme weather event that maybe has through some really complex nonlinear connections back to some kind of climate change forcing, but that would be really, I think it's going to be difficult to untangle that part of it. But again, those studies will come out, I think, in the coming years.
But one of the things about these heat waves is that you basically need the air masses to be stagnant and persist and to heat up and to warm over a period of days. And this sort of pattern in the jet stream favored that ridge to just kind of hang out.
Right? It's a blocking. Yep. Totally blocking.
It's a blocking pattern, right?
Yep. And there's subsidence. Yep. Subsidence in the atmosphere. So that kind of pattern, with a high pressure system, is that part of that pattern is actually sinking air is warming. And so that's part of the surface heating that goes on.
And you don't tend to get these patterns at this time of year. Is that correct?
I don't know. I went into the literature to look a little bit at blocking patterns, and I didn't get real definitive answers. I think they're more common in the spring and the fall and the transition. But again, the summer is a time when the jet stream is starting to weaken and slow down. So maybe there's some aspect of that too. Again, I don't know enough about that climatology for that particular region, but clearly the level to which some of the stations are broken. So I was wrong, Zach, in what I said offline. I'm looking at some of these, they're broken by 5 to 10 degrees, I think, in Celsius, looking at some of these Canadian records. But that's huge. It's still huge. That's not, it's striking to have something crushed by that. Because usually, like we were talking about before, you nibble at records over time, right?
Right.
Is that, you break it by a couple of degrees and then you have to have an event. And it's hard to do because records are records. Again, climate change and trend makes the nibbling at those records a little bit easier. But this is when you break something by 5 to 10 degrees, you got to have some other kind of dynamical weather pattern really aiding and abetting that kind of record breaking going on.
And is that at all just related to the sort of persistence of that ridge, that it didn't move out quicker and so it stayed there for a little bit longer? And then of course you can just create more.
Yeah, that's right.
Warmer,
blocking patterns. Right. Blocking patterns can lead to persistence. And, like you said, the daily high is often conditioned by the previous night. That can really vary depending on the location. But, if you've got warm overnight temperatures, then your jumping off point for the next day is a little bit higher and a little bit easier to reach it. So that persistence can sort of string them up and peak, and you end up having those extreme temperatures over a run too. And there's some feedbacks, I think, within having a multi-day event like that as well.
All right, let's put a final bow on this and then move on to the monsoon. But I'm just thinking about like the overall sort of regional pattern that produced these two heat waves. And both of them were ridges. The Pacific Northwest one had a different kind of shape. It was, as you said, the sort of omega looping, if you will. What are the main differences in the patterns between these two heat waves?
Well, I think that one was so anomalous.
The Pacific Northwest one.
Pacific Northwest one was so anomalous. The way that temperatures were broken and by the magnitude that they were, and that was related to that very unusual kind of pattern. Our heat wave was pretty typical, as far as the way it looked. I mean, it was early. The way that the ridge came in and how quickly it did was fast. It's like to get the ridge to move that far north and to get the Four Corners High to set up in a really like solid way, right even before our kind of typical Father's Day weekend. Like remember in our past heat waves, we would talk about this. The ridge would be moving overhead right around Father's Day. And so you can even think about this one as it being even further north, about a week ahead of schedule. So that, that stands out as a bit unusual. But again, this is sort of the variability of weather from year to year in that June pattern. I don't think we necessarily crushed any of our records. We nibbled at them, and we'd had some in recent years, very hot runs. And like you said, you pointed out how anomalous last June into July and into the rest of the summer really was on as far as the heat. So this one is not it stands out. It was a really epic, very impactful heat wave. And I think it exacerbated a lot of the fire activity for that period of time, and so I think fire suppression was really hampered during that period because it was just, you're getting 24 hours of burning period, which is unusual. Again, because we had those heat wipes. So I don't even know how to finish this rambling train of thought. So finish it for me.
I'm going to finish it for you. I'm going to finish.
Thank you.
I'm going to finish June. So I think to everybody's happiness that we can look back on June. It is the least favorite month. At least it is my least favorite month.
Yeah, but don't put it away yet, because that ridge led to really rapid onset of early season monsoon moisture.
Great segue. That was going to be my question.
That was your segue. Okay, good.
Yeah. But that is the question, Mike. So there is a connection here between that ridge creating that heat event and what's been the beginning of the monsoon season. So, I'm looking out my window right here, Mike, at University of Arizona, and there's very tall, what looks like thunderous cumulus clouds, and I'm excited, and particularly after the monsoon last year, we've got something to talk about right now. So it's been an interesting early monsoon season. If you look at the dew point data here in Tucson and actually Phoenix, like today would be the historical start. I guess actually, do they so that dew point metric is 3 consecutive days above 54 in Tucson or 55 in Phoenix, or do I have it backwards?
No, that's right. 54 in Tucson. Yep. Daily average dew points for 3 days above that.
Then would the onset be the first day of the 3 consecutive days?
Yes.
Okay. So today,
I think that's right.
Yeah, I always get that wrong. So as of Friday, July 2nd, that marks the 3rd consecutive day of dew point temperatures above that threshold. So at least according to that metric, which we don't use anymore, but is illustrative because it signals the amount of moisture around, that the monsoon, basically began slightly early, but certainly within the bounds of what often happens. And given last year, we'll take it.
Yeah, and you can even think of previous years. And again, I'm doing this from memory, and I am an actual data-driven climatologist, and I don't have this data in front of me. I could have it in front of me. I could actually look it up. It certainly feels early, and I think climatologically, using the little dew point definition, we'd be a little bit early. And even in past years, we've had struggled to, see good solid onset until, a week or two. This is in southern Arizona, week or two into July. So, this is pretty striking to me to have this much moisture and this kind of afternoon convective activity across the Southwest this early, which is great. It's almost feel like we kind of earned it to get up to this point.
When you look across at some of these stations, like there hasn't been a lot of rainfall, but there's been some. I think there's been a lot more in the places where we don't have good monitoring on the mountains. Just visually looking out at Mount Lemmon, and I have seen on my radar app over Mount Graham and other high country that there's been quite a bit of activity. But it's maybe foolhardy to talk about totals at this point because they're so low. But I think maybe the important part is that there has been a little bit of rain in the valleys, more so on the mountains.
Well, there's been some kind of interesting patterns that have emerged so far this season, and I'm trying to find the tab. What we saw early on, it was right after the ridge. It was at the way that our heat event actually ended was that we started to have sort of deep moisture flow in on the southern side of the ridge, and the ridge sort of built further north. And so we got in sort of deep easterly flow. And so we started actually seeing convection forming and clouds moving around. And then we had a trough of low pressure that edged in from the west, which gave us some good dynamics. So mid-level cooling. So then you started to see the low deserts actually get precipitation like the 3rd week of June, which is really weird. But again, it's very transition-y. It's kind of what you see on the way in and the way out. Do you remember us talking about Tropical Storm Bud a couple of years ago, where we had that monsoon onset right on June 15th and big widespread rain event? This wasn't quite as spectacular, but it had some of that flavor to it where we had a low pressure system with some dynamics actually kick off. So thunderstorms. So there were areas of southwest Arizona and up along the Colorado River that got just hammered with inches of rain in June, which is kind of weird. Phoenix ended up getting precipitation through some of these events. And then more recently, we've seen the Mogollon Rim, parts of northern Arizona, even northeast Arizona, and then parts of southeast. But again, it's been interesting. The wettest parts of Arizona have been the locations that usually see the latest parts of the monsoon onset. So it's been a little bit on its head. So typically what we'll see is that southeast Arizona will get into action first and it'll kind of spread towards the northwest. It's been on its head. We've seen more action in the northwest, southwest, and southeast has been drier than average so far.
So we also had a hurricane form in the East Pacific, Enrique.
Yeah.
Right? And it had a sort of a favorable trajectory that I believe drove some moisture up the Gulf. Did that contribute to sort of the southwestern part of the monsoon region as getting the early rain?
Yep. With the Four Corners High and the ridge displaced north, we've got into sort of deep easterly flow. So Mexico has kind of come online with convective activity. And so that had initiated some Gulf surges. And then Tropical Storm Enrique decayed right at the mouth of the Gulf of California, which initiated a surge. So we have this pretty decent, consistent, slow seep of moisture that's been pushing up into the low deserts of Arizona, and it's pushed precipitable water amounts. I was reading the forecast discussion out of the Tucson office today, and I thought I remember reading that it was a record for the day. At one of the stations, it was a record for the day because it's so early in the season. But it's a high amount. Anywhere from like 1.5 to 1.75 inches is a lot of precipitable water for this time of year.
Yeah, you were saying earlier offline that it feels a lot like August right now, and that this monsoon season sort of started very quickly, didn't give a lot of warning, or there wasn't that sort of teasing going on ahead of time. It was sort of not there and then there. And that was something that, I mean, each monsoon has its own flavor, and maybe that's what this one looks like, at least in the beginning. What were your thoughts there?
Yeah, it does. I mean, it feels like a late July, early August kind of day with the way that we have got so much moisture parked over here. It's close to that too wet to rain situation, woke up to clouds from previous activity. We've got a nice inverted trough, which is a little upper level area of disturbance that's been moving really, really slowly across the borderlands between New Mexico, Mexico, and then Arizona, Mexico. It's been moving west for many days now, which is, again, these are great. It's pretty monsoonal. We've got upper level, easterly flow. It's so early in the season, though. It could be that we get another sort of like repositioning of everything, and then we do kind of what we normally see with that early season. Maybe we dry out a little bit, and then southeast Arizona comes back online because we're doing a little bit more sort of the typical kind of monsoon season warm up, and then we're confined to having that convection on the mountains for a little bit here too. And I also want to leave New Mexico out of the discussion. We often do, and I'm just kind of looking at the pattern of precip over the last couple of weeks there too. Is that seen a lot of the spring is that the east side of New Mexico has gotten a lot of precip, and they had a couple of really big days in this last week. And it's started to reach over into southwest New Mexico. But again, it's kind of what southeast Arizona has seen too. Southwest New Mexico hasn't seen a ton of activity yet as well. And again, it's early, and we'll just have to see how things shape up for the next couple of weeks. The outlooks look really good for the rest of July, and then it kind of falls apart after that. We're not totally sure how the rest.
It's a little bit far in advance, though.
It is. We can talk a little bit about.
Let's go over the forecast in a minute, but I want to go back to the New Mexico, Arizona comment, because I'm looking at a plot that actually you made, Mike, that I hadn't seen before, that I think is really, really quite interesting. And so you're looking at, you're tallying the percent of the state, both states that experience at least a trace or of rainfall, and you can do it in real time. So for this year, but you've also got a nice sort of climatology on there where the percent of the state with rainfall sort of ramps up it actually peaks maybe in mid-July in Tucson, which I thought was interesting, and a little bit later in New Mexico. And it also peaks, the percent of New Mexico that receives coverage, the peak of that is right around 37% of the state in any given day. In August has rain. That would be the average. So
on average, right? Yeah,
an abstraction there. Whereas Arizona's peak in coverage is about a quarter of the state. And so just looking at these two plots, I mean, for New Mexico, pretty much every day, most of the days since June 15th, there's been greater than the average aerial coverage, which I think speaks to what you were just saying a minute ago. But beyond that, I'm just curious why New Mexico has more aerial coverage on average than Arizona. Are there different ways that New Mexico gets the rainfall? So it's not just a sort of monsoon southern forcing, but there's actually, it's closer obviously to the Gulf of Mexico, so there could be some things coming in from the east. What's going on there?
Most likely, and I would have to look at this a little bit more closely, is that elevation is the strongest determinant in the monsoon season of whether or not you're going to see precipitation on any given day. So it's, because I'm also using prism data, which is scaled to elevation. So it's a little bit of autocorrelation there. So it could have something to do with the extent of land area in each state that is at some critical elevation that would see precipitation. That's probably the most strongest determinant of that daily precip pattern. And that's that other study we're working on too, is that, you see, like a typical monsoon day it's elevation, right? And then what's the next level of monsoon day? It's elevation with some movement to lower elevations. And then what's the next, when you kick it upstairs, what's the next level? It's storm organization off of elevation that moves into valley locations, and then the rainfall extent. But it always points back to elevation, starts there, and then it kind of grows from there in extent, in magnitude as well. And it's only the really rare instances, which can be big rain events, where you get something like deep tropical moisture and some crazy outflows that aren't really, maybe they probably point back to elevation at that point, that you end up having, heavy rain at lower elevations that's not necessarily tied back to elevation.
Moisture and winds.
Yeah, and topography first.
Moisture first.
Moisture, that's right. Yeah, moisture first. Well, you can have marginal moisture, and topography can often capitalize on it. But then wind, and then moisture again, because you got to have deep moisture, lower elevations to kind of get it to go. And then you've got some kind of upper level organization that's going to relate back to winds, vertitrough, some kind of circulation pattern, and then tropical storms kind of are part of all this. They can be organization, they can be part of the moisture source. And then, if you get something in September where you actually get the circulation center and the moisture overhead, it can be really beneficial, and often nothing at the same time.
Yeah. I mean, the topography is so critical because it provides the mechanical uplifting to bring that moisture air at the surface up into higher elevation. So so it sort of helps with that. And when you don't have like good steering winds, or if you don't have other sort of atmospheric dynamics at play, you can basically just have rainfall that's occurring on the mountains and nowhere else, just because of that topographic influence on uplift.
Yeah, and just to kind of wrap up this June segment too, I wanted to pull a couple of observations here. I'm looking at the rain log network, which we have quite a few observers in Tucson and Phoenix, and this has been really interesting to watch over the last couple of days, because we were talking about earlier is that I think the airport actually has recorded some precip. It's not been much, and the bar is really low for June. But the way that the monsoon has evolved so far has been a lot of afternoon convection on the mountains around Tucson. You see that across all the Southwest. It's like blowing up in the afternoon, and then steering winds have been light, so we haven't had a lot of movement off the mountains. But in the parts of Tucson and northern Tucson, I've seen this in past summers, we've seen this before, is that if you're kind of close to the mountain, some of these storms will be really narrow and they'll kind of drift off the mountain. And so we've got, total precip amounts in parts of Tucson that are 1.5 inches. And this is probably 10 miles from my house. I've had 200s. And so this is up probably straight north of you, Zach. Mm-hmm. And then we've also had a storm event yesterday that was to the northwest here. Again, localized precip amounts of 1.5 to like almost 1.75 inches. And that's a couple of events in June. That's pretty dang good for some of these locations.
I was reflecting. I still feel like I'm in a little bit of psychological shock from the last 2 seasons, because it's been hard to feel like the monsoon is here. But Mike, I think there is no way to characterize it other than that it's kind of been a pretty good beginning. It's exceeded our expectations. Obviously it exceeded last year, but I think even in the best case scenarios, this is sort of a good start. And so I guess the question is what's your take on whether or not this start will last? Is this a harbinger of, a good monsoon season, or you're not willing to make those kinds of statements?
Well, we have to talk about our fantasy monsoon guesses. So I guess I'll kind of lay my cards out on the table. So it's weird. It's so psychological. And I really feel like if we had a psychologist on this podcast with us who just like ask us probing questions and be like, well, how do you feel about that? And like, well, why do you think that? That would be really helpful for us. Because I think that this is more emotional release for anybody than science content in this podcast. I've got, on one hand, I think it's great. It shows the monsoon isn't broken. Getting precip down in the ground and in the soil and starting the green up that we're going to need in some of this vegetation that will help recycle and hold on to the humidity, which we never really kind of got going last year. I think became a vicious cycle downward. And we know this in some of the research is that moisture recycling becomes an important part of the monsoon in the core. So it's early. Getting some of this precip down is really helpful. The outlook for the next couple of weeks to the end of July through the Climate Prediction Center, the 6 to 10, the 8 to 14, the 6 to 10 shows a slowdown for the next week and a half or so as the high repositions and sags a little bit south. The 8 to 14 and then the week 3-4 forecasts are still showing above average precipitation through the end of the month. So that's encouraging to me. I think we're going to have to take this month by month because the outlooks for August and September have a lot of uncertainty, and they're also been trending down a little bit too. But again, they don't have skill associated with them. So I don't really know what they're latching onto, and we'll just have to kind of maybe take a look at that one later in July when we reconvene.
I'm certainly excited and encouraged by the first part of this monsoon season. It hasn't rained at my house yet, but I'm okay with that. I'm looking out the window.
Are you really okay with that?
No.
I had anger one of the other days where I went out and watched. It was not healthy. I'm like, I got to get this under control. Like, this is not healthy to go out and watch it rain in another part of town and be like angry.
If there's rainfall around, it's going to happen. It's going to happen at my house.
Yeah.
And, it's more, for me, it's more like, fast forward a couple days and this moisture leaves and if I didn't get any rainfall at my house, I'd be, disappointed, obviously, because I missed that window and it's hard to get those windows back. But it's not like last year. We're going to have a lot more to say when we do our next podcast in terms of the monsoon. July will be in our rearview mirror at that point. But so maybe we can move beyond the early onset and talk a little bit about what people are thinking their guesses are, their forecasts are for the monsoon. And I think it's pretty encouraging. So for those of you, we just want to thank everybody for showing interest in the Monsoon Fantasy. It's our first formal attempt at engaging with the public here and seeing how they think about the monsoon in each of these three months. So, Mike, we had quite a bit of enthusiasm about the Monsoon Fantasy. On the order of 330 people signed up for it, and and we had quite a bit of spread on what people forecasted for all five of the cities. And just to reiterate, for those who don't know, we created this platform where anybody can sign up and make a forecast for five cities: Tucson, Phoenix, Flagstaff, Albuquerque, and El Paso. And they score points based on their accuracy of their forecast for a particular month. So they do it for each of the 3 months: July, August, and September. And they score points based on the accuracy of their forecast and how risky their forecast was. So, for example, it's more likely, Mike, if you were to bet that Tucson's rainfall in July would be 2 inches, it's more likely that would occur than, let's say, 8 inches, obviously. So you'd get more points if you bet 8 inches and 8 inches actually fell than if you bet 2 inches and 2 inches actually fell. So you accumulate points both through forecast accuracy and riskiness. And so, Mike, I'm curious, we haven't talked about this yet, but were you optimistic? Were you pessimistic for your 5 cities? What were your forecasts?
I just looked it up. You could guess that I was neither. I put in 1.85, which was
1.85 for, are we talking Tucson?
I'm talking Tucson. I'll go through the rest of mine. So I think I was pretty close to the median, if not the median, for most of those cities.
Yeah, that was predictable. You're sort of down the middle, Mike. I was bullish. Yeah, I went 2.65 inches in Tucson. I was below median. I think I was right around median for Phoenix at 0.8 of an inch. I had 2.9 inches in Flagstaff, 1.75 in El Paso. El Paso, believe it or not, is seen a lot of activity. Actually, I believe July, it got more rainfall in June in El Paso than it had all of last year.
That's crazy. And I'm actually really glad we didn't have July as part of the
You mean June.
I'm sorry, June. I'm glad we didn't have June, because June that would be our high stakes game for next year. June can be gnarly.
Well, everybody would bet zero. It'd be for most, half the year is like everybody would get a perfect forecast.
Yeah, but what if you put out, you wouldn't get any points for putting zero. I think that would be the way
you could really distinguish yourself, however.
Yeah. If you would have guessed something like 1.5 inches for one of these stations in June coming out, I mean, that would have been impressive. If you would have done something like 1/4 inch for Phoenix, that would have been impressive too.
All right. So basically you were like average for these cities for July, huh?
So Tucson, I have 1.85 inches, which is the median. I've got 0.85 for Phoenix. Did you have 0.8?
I got 0.8. Yeah.
I'm going to edge you out on that one. Flagstaff, I put 2.5 inches. El Paso,
I had 2.9. So I'm
okay.
I'm more optimistic than you.
More optimistic. El Paso, 1.25.
I had 1.75.
Okay. And then Albuquerque, 1.05.
I had 2.25. I don't know.
2.25.
I don't know what I was thinking there. I was some rogue storm from the north.
Yeah, I'm a little worried about New Mexico because the forecasts for months now have shown New Mexico being a little bit drier than Arizona. Science, baby.
Wait, so why are you worried about that?
Well, I'm worried because I'm worried for them that they're not going to. That's why my guess is quite a bit lower than yours.
Yeah. I was flipping. No, I wasn't. I was scouring. I was trying to data mine on these. I feel pretty good. And look, Tucson. I feel pretty good about Tucson's above average forecast. My above average forecast for Tucson.
So I'm watching the radar right now. We're July 2nd, and there are storms forming across Tucson, and it'll be really interesting to see which ones cross the airport gauge or not.
I didn't mention that people can see how they're scoring in relation to other people. So we have this cool leaderboard. It's a lot like March Madness. And we've got a couple cool prizes. You can still play. Obviously, July's locked, but August and September, you can still get in and play and win the if you're exceptionally good at forecasting, you can still win. We actually kind of did this amongst our friends last year, and a person who just played in August and September won just because he had such pessimistic forecasts in August and September. So it's still possible. But I wanted to say, Mike, that we have quite a diverse group of people that are interested in this, and I think it just really reflects how much the monsoon captivates people's attention here in the Southwest. So we had people self-assess their levels of expertise, anywhere from novice to all the way to expert. Mike, what did you pick?
Put advanced.
So we had 5 tiers: novice, advanced, beginner, intermediate, advanced, and expert. You put advanced. I would have called you an expert.
Okay. Then we're in trouble. That's just a problem right there.
But we had we had quite a bit of novices, quite a bit of advanced beginners, a number of intermediates, less advanced, and only a handful of self-described. People are being modest, self-described experts. But yeah, it'll be interesting to see if the so-called novice outperform the advanced or the experts. We also had we asked questions about what sort of the 5 cities, what city people's most identified with, or where they felt their climate expertise was the greatest. And not surprisingly, because we did a lot more media here in Tucson, but most of our players are actually identifying with Tucson as being the city that they're most familiar with in terms of climate. 250 out of the 330 people identified Tucson, 58 for Phoenix, and less so for Flagstaff, Albuquerque, and El Paso. All right, so looking forward to seeing how that unfolds. Mike, monsoon's here. Anything else you want to say about it?
I'm feeling good, at least for this month. So we'll just have to help each other through the next couple of months. But yeah, hopefully we'll get back together in a couple of weeks and talk about how much rain I had at my house and how you didn't have at your house. And then we'll get Ben back in town. He can check his rain gauge. All
right, Mike, excited to do this in a month or so, or maybe we'll do it a little bit of higher frequency like we did last summer.
Yeah, major props to you, Zach, because you really organized this Fantasy Monsoon thing and got us organized and got some cool stuff together. And we got Ray's team, and we want to make sure at some point we recognize the developers by name who put this really cool interface together.
That's right. Yeah, we had Ray Granillo, CJ Larson, Benny
Delgado. Right?
Delgado, yeah. Some really talented developers that actually helped us put this together. And this
Dharma,
is going to be something that
evolved. Don't forget Dharma too. Dharma came up with our whole point scheme too, data science and statistics expertise.
That's right. Thanks, Mike. But yeah, this will be something that evolves. We're road testing it this year. It's going to continually improve. So give it a check if you haven't already. And don't forget to make your forecast. We'll send out an email. You got to make your forecast a week before the start of August. So you can't game the system by looking at the weather forecast.
So Zach, what's the deadline for making your August? Because I've got to make sure I don't miss it either.
Yeah, no, it locks within a week. And so you have to be a week outside of whatever, I don't know what the exact date is for what that would mean for July, 24th?
Yeah, so we got a couple weeks to make that August prediction.
All right, Mike, good to talk to you, and talk to you soon about weather and climate here in the Southwest.
Happy monsoon, Zach. Enjoy.
Thanks. What are the chances that the Southwest Climate Podcast can be the next Joe Rogan experience?
I think really, really small.
we need to step up our game.
What? Like which part of this?
I don't know.
This will have to get edited out.
In terms of niche climate podcasts on the Southwest, we've got the corner.
Yes, boutique climate podcasts. Absolutely.